Hello, and welcome back to Impossibly Practical, where we overthink so you don't have to. I'm Sai, and today we're talking about a topic so infamous and infamous that it's basically a scientific paradox, the space elevator. Now, before we start, it's important to remember that I am not a scientist. I'm just a guy who overthinks for a living. I'm just a PNG on your screen. I'm not omnipotent because I read a Wikipedia article. Now, with that said, let's get into it. Space elevators are a staple of the sci-fi genre, appearing in many novels, movies, and video games. Typically, a space elevator is a megastructure that extends into space, or more accurately, orbit. They are used to put things in space without the use of rockets. On paper, it's a great idea. Let's remove the hardest part about rocket science, the rocket. Supposedly, they are a more reliable and reusable method for getting things into space. They're a whole lot less violent than rockets, so delicate pieces are less likely to break on their journey to space. But here's the real question. How do you make one? A space elevator is a rather difficult structure to build, as its massive size makes it nearly impossible to make. So, how do you make a space elevator? I got a few ideas. Idea number 1. The tall tower. The obvious choice. Just make a really tall building. We make skyscrapers all the time, but the scale is wildly different. Take the Burj Khalifa. It is 830 meters tall and 55 meters wide. That's a 15-to-1 ratio. So if you were to make one to go to low orbit, it would have to be 82 miles wide, or over 133 kilometers. That's not exactly practical. Plus, if you wanted to suspend part of it in space, it would snap in half. Buildings are made out of concrete and glass, because they're made for compression, not decompression. Basically, they are built to hold their weight, not be pulled apart. So that idea doesn't really work. And that leads us to idea 2, the space rope. If you just suspend a rope from the sky, you can climb into space. But to hold a rope, you need to hold it both up and down. To hold the end up, you will likely need some sort of space station. And this is where I become your science teacher for a bit, and where we learn about geostationary orbits, also known as a GEO. A geostationary orbit is when something orbits above one constant point. So the station needs to be in a geostationary orbit above its base. A geostationary orbit takes place about 36,000 kilometers up, or 22,000 miles off the ground. To sustain this orbit and hold the cable, you would need to fuel up the station consistently. You would also need to have a very strong cable to not only hold its weight, but also the weight of the elevator and its cargo. Not to even mention the foundation you would need to hold said rope down. It's safe to say this idea is a bust too, but what if we mix the two ideas? A happy medium, if you will. Here's idea 3. It takes the structure of a building with the ease of a rope. Just have a skyscraper built at the rope's base, so the building can hold part of the rope's weight and hold it down. The building allows for close storage of needed supplies, like fuel and personnel, and the space station allows you to keep the rope taut. Now that we have an idea for what this will look like and how to make it, how will we use it? Of course, there are many practical uses, such as easily taking things into orbit, especially with delicate components. This can also let people go to space without special high-G training. This could also allow for more efficient solar panel usage. Lots of the light that reaches Earth's surface is scattered by the atmosphere. So, if you had tons of solar collecting satellites, they could collect the energy and send it back to Earth through lasers. They can all shoot their lasers at the top of the elevator to send the energy from a range, and then it can pass the energy down by electrifying the cable. Alternatively, you could put a space telescope on top, or a radar to find asteroids and other space debris. You could also have a massive cell tower, or as a way to easily communicate with satellites nearby. It could reduce latency, or allow for faster communication. You could send people up it too, to observe space, or just have one of the best views possible. If you wanted to monetize it, you could turn it into a parachuteless skydiving experience. Since all things fall at the same speed, you could move the elevator down fast enough to allow you to fall inside the room, for one of the craziest skydiving experiences you'll ever have. So clearly, it's very useful for both practical and impractical reasons. So it's safe to say, at first, they may seem practically impossible, but with enough work and enough thinking, it may turn out to be impossibly practical. Thank you so much for watching. I really enjoyed making this video. I will try to upload weekly, but that may seem to be impossible with school starting up soon. If you want to drop some feedback or any ideas for future videos in the comments, I'd appreciate it. I will try to respond to every single one. Thanks for listening. I hope you learned something, and I'll see you next week.